Okay, I'm back, and what I've actually got here is two systems. I've got the original, although I changed pulleys and rope, and I've converted what was the original, I don't know why I did this, would have been easier just to left it as it was, to a different type of system. And I wanted to do that so we could get some comparisons of some things as we went on. Basically what I did is I took the pulley and brought it down here, disconnected the load and connected it to the pulley. I took the end of this rope that used to connect to the load and connected it up here to the anchor. And I've got just a safety knot here so this thing won't fall to the ground with us. So there's a difference in these two systems. I want to go through that difference real quick and then look at some other things that are involved with this. First, let's look at the pulley principle. If I have 1 pound of force here, I have 1 pound of force here. These two forces add. Now they're in an up direction rather than a downward. But 1 plus 1 would be 2 again. So we'd have a force of 2 pounds here. Now I can't have 2 pounds since I don't have a 2 pound weight here. So let's see what we do have. If I have 1 pound here, half of that weight is supported by this line and half of it by this line. So half of 1 pound is 1/2 pound and 1/2 pound, and notice they are equal. 1/2 pound, 1/2 pound of force in each one of these. But the difference is this. If I'm having to support this load with my own force, how much force does it take to hold or move this load that's 1 pound, or 100 pounds for that matter? Half of it. Because half of the load goes here, which is tied to an anchor, and half of it comes over here. This time, that 2 to 1 from the pulley, remember we always get a 1 to 1 redirect. Here it is. What's the force in this line? 1/2 pound. What's the force in this line? 1/2 pound. What does it do? It just redirects. We now have a 1/2 pound on the load and twice the force, on the anchor, and twice the force on the load that I have here. That's where the 2 to 1 comes from. So we see both the 1 to 1 redirect and the 2 to 1 is directed toward the load this time instead of the anchor as it was in this system. And basically, this system is just this system turned upside down and the load connected here instead of here. Now that's important because you can take a block and tackle system that's rated 4 to 1 and you're pulling this way, flip it upside down and pull up, and you got a 5 to 1 just by switching it upside down. So one of the things we notice then is whatever force I apply here is doubled toward the load. It is not toward the anchor. And only half the load is at the anchor and half the weight of the load or force due to the load is on me or my pull line. Now there are two other things that happen in pulley systems that are of some concern. On a 1 to 1 system, if I pull my pull line 1 foot, the weight goes up 1 foot. On a 2 to 1, if I pull this 1 foot, this only comes up a 1/2 foot. So that 2 to 1, as far as the distance the weight load travels, is 1 to 2. It travels 1 foot for every 2 feet this travels. So this has to travel twice as far as we want the load to go. So if we had this hooked up, we want this load to move up 20 feet, we have to pull this up 40 feet. In this case, if we want this load to move up 40 feet, we pull this down 40 feet. Whatever we want it to move, it moves up the same amount we pull. The 2 to 1 system here, we have to pull twice as much as here. The other thing about this is the velocity, or I guess the speed would be a better word here. Whatever rate of speed I pull this at, if I'm pulling at 1 foot per second, my load travels at half that speed. It is 1 to 2. So let's do 2 feet per second. If I do 2 feet per second, this goes up at 1 foot per second. It has to move half as fast. On our 1-to-1 system, if I move this 1 foot per second, that goes up at the same speed, 1 foot per second. If I pull this 2 feet per second, that goes up at 2 feet per second. So the three things that are affected by mechanical advantage is the force. It's either 1-to-1 redirected or it's a 2-to-1. The distance the load travels half the distance in a 2-to-1 or the full distance in a 1-to-1. So that force multiplication, 2-to-1, 1-to-1, or what we would call mechanical advantage, also determines how much the load will move with respect to how much the pull line is pulled, and it also affects how fast the load will move compared to the speed of the pull line. Now, in the next segment, I'm going to do another pulley up here so that if we had to pull this higher than we could lift, we could put a pulley way up there somewhere and redirect the force back down. And we'll look at how that differs than that. And then I'm going to start to define a simple, compound, and complex pulley system. And I'll start with a simple. And then we'll define the other two when we get to them.